Here is an Alex topic where we want to find all of the zeros of the function. So this function 3x to the third minus 8x squared plus x plus 2 is not factorable. So the process is, first look at the degree, which is 3, and we know that we're going to expect 3 total zeros. Now list the factors of the leading term. The leading coefficient is a 3, so the factors of 3 are 1 and 3. And list the factors of the end term 2, 1 and 2. The end factors are the p numbers and the leading factors are the q numbers. So first I'm going to create a possible list of zeros that might work, and it's plus or minus p's divided by q's. So I stack these and I start with the first p number, which is 1, and I do 1 over 1 and 1 over 3. 1 over 1 is 1, 1 over 3 is the third. And the second p number is 2, so I have 2 over 1 and 2 over 3, which is 2 and 2/3. Next you're going to test these zeros by plugging them in to the original function. So if I test x equals 1, that's the easiest one to check. That's the only one where you can actually ignore the letters and you just type in the coefficients from left to right. 3 minus 8 plus 1 plus 2. Type that in your calculator to find that sum. Now you will get -2. So that lets me know that 1 is not a zero of the function, because the value that you get on your calculator is the remainder if you divided it. And I want to get a remainder of 0, which indicates that it divides evenly. So if you test these and plug in, +1, +2, I checked 1/3, they do not work. The only one that worked was 2/3. So this is what it looks like when I plugged in 2/3. 3 times 2/3 to the third minus 8 times 2/3 to the second plus 2/3 plus 2 equals, and I did get a 0. When you find one that works, you're going to put that in the box and do synthetic division. And so with my list of zeros, I'm expecting 3 of them. Right now, 2/3 is a 0. So now I'm going to put 2/3 in the synthetic division box, and I'm going to write out my coefficients of the polynomial: 3, -8, +1, and +2. Drop down 3, multiply by the box. 3 times 2/3 is 2. -8 plus 2 is -6. -6 times 2/3, -4. 1 plus -4 is -3. -3 times 2/3 equals -2, and 2 plus -2 equals 0. So you get the remainder of 0. And now the 3 and the -6 and -3 are the coefficients of your reduced polynomial. So if you originally started with an x to the third, then this first coefficient 3 will now be 3x to the second. You always reduce your degree by 1. So put your letters back in. 3x squared minus 6x minus 3. Your goal is to get it down to an x squared, because at that point you can use the AC method of factoring, or you can use the quadratic formula to find the remaining zeros. I'm going to use the quadratic formula. It's x equals -b plus or minus square root b squared minus 4ac all over 2a. Now the a number is 3, the b number is -6, and the c number is -3. So I get x equals -b. So if b is -6, I change it to +6, plus or minus the square root of -6 squared minus 4 times 3 times -3 all over 2 times the a number 3. So next, type in the problem that's under the radical. Make sure that you do type the parentheses around the -6 when you square it, but this sum gives me the answer of 72 when you enter that in. That's -6 squared minus 4 times 3 times -3 equals 72. So now I have a fraction, 6 plus or minus the square root of 72 all over 6, and 72 is not a perfect square. So I need to find a list of perfect square numbers and find one of those numbers that will divide into 72 so I can simplify it. So perfect squares start with 1. 1, 4, 9, 16, 25, 36, 49, and that's a good start there. So let's kind of look at these numbers. Now, 72 is divisible by 9, but it's divisible by 9 8 times, and so I can break down 8. So I'm going to check to see if there's a bigger number, and actually 36 goes into 72. So you want to pick the biggest one. So I'm going to break down 72 inside as 36 times 2. So I have 6 plus or minus the square root of 36 times 2 all over 6. Now, with a radical, with a product, you can actually break the product up. It's the square root of 36 times the square root of 2. So that simplifies to 6 square roots of 2. So now I have 6 plus or minus 6 square roots of 2 all over 6. And so here you can distribute the division, and you have 6 divided by 6 plus or minus 6 square roots of 2 divided by 6. And now I simplify. 6 divided by 6 is 1, so I have 1 plus or minus, and then 6 square roots of 2 divided by 6 is just the square root of 2. So my final list of zeros are 2/3, 1 plus the square root of 2, and 1 minus the square root of 2.